Okay, chapter 5.4, talking about medians and altitudes. Today we're going to learn to identify properties of medians and altitudes of a triangle. Okay, theorem 5.8 says this, the concurrency of medians theorem. The medians of triangles are concurrent at the point that is 2/3 the distance from each vertex to the midpoint of the opposite side. So let's make sure we know what a median is. Median sounds like the middle, like the median of a highway. So the median is nothing more than the midpoint of a line going to the opposite vertex. Midpoint of a line going to the opposite vertex. Midpoint of a line going to the opposite vertex, okay? And what it says here is from the vertex to the point of concurrency is 2/3 the segment length. So FC right here is 2/3 of FH. EC is 2/3 of EG, and DC is 2/3 of DJ. Okay, in a triangle, the point of concurrency of the medians is called the centroid. Okay, the way I think about it is the median means the middle, and the centroid means the center. So the median and the middle, okay, and the center of the centroid. This is also the center of gravity of the triangle because it's the point where a triangular shape will be balanced. For any triangle, the centroid is always inside the triangle. So here we go. In the diagram at the right, segment XA is 8. What is the length of XB? Okay, we could set up an equation, but I like to think of when we're dealing with centroids, everything's in thirds. So this is 2/3, and that's 1/3. So if 2/3 is 8, that means each third would be 4. So segment XB would be 3 times 4, which would be 12. If you wanted to set up the equation, it would look like this. Segment XA is equal to 2/3 the entire length of XB. Well, we know XA is 8, so 8 equals 2/3 XB. Well, multiply each side by the reciprocal, so multiply each side by 3 over 2. 3 over 2. The right side cancels. That cancels the 4, so I get 12 equals segment XB. Alright, now it says in problem 1, ZA equals 9. So let's look at that real quick. ZA equals 9. That's the long segment. That's 2/3. What is the length of ZC? So what is the entire length? So ZA is 2/3 of ZC, or we could say 3/2 of ZA equals ZC. ZA is 9. So 14.5 when you do the math is ZC, in whatever units of measure it was. What is the ratio of ZA to ZAC? Well, AC is 1/3 of ZC, and ZA is 2/3 of ZC. So we could say it is 1/3 to 2/3, or we could say it's a 1-to-2 ratio. Alright, so ZA is equal to 2 times the length of AC. So it's a 2-to-1 ratio. How can you identify the altitude of a triangle? We'll talk about altitude on the next slide. The altitude of a triangle is a perpendicular segment from a vertex of a triangle to the line containing the opposite side. It can be inside, outside, on the triangle, or it could be a side of the triangle. So here we go. For triangle PQS, PR is a median. See how it's perpendicular to a vertex? Altitude or neither. PR is a median, is the altitude, because it is going from a vertex to the opposite side, and it creates a vertical or a perpendicular line. So Since PR is a segment that extends from the vertex P to the line containing SQ, the sides opposite are perpendicular, so it's an altitude. For triangle PQS, is QT a median, altitude, or neither? Well, point T is a midpoint of PS, and it goes to the opposite vertex, so it must be a median. It must be a median. So, segment AD. D is a midpoint, A is a vertex, so AD must be a median. EG, it's neither a median or an altitude because it doesn't go to a vertex. CF, okay, so it starts at a vertex and it goes to the perpendicular of the opposite side, so it is an altitude. Okay, so let's just double check. Is AP a median or an altitude? Well, P is a midpoint and A is a vertex, so it's a median. It is a median. So if AP is 18, that whole length right there is 18, what is KP? Well, we know KP is 1/3 of AP. So KP must be 18 over 3, so KP must be 6. All right. If BK, next question, if BK, let's look at BK, is 15, that's 2/3 of a segment. What is KQ? That is 1/3. So remember the way we thought about this is KQ, 2 times KQ is equal to BK. So KQ is equal to 15 over 2, which would be 7.5. Which two segments are altitudes? Well, this might be like a trick question. It's a right triangle, so BA is an altitude and CA is an altitude. Okay? Easy enough? Moving on to the next segment. Now we're going to talk about the orthocenter of a triangle, okay? What is an orthocenter, okay? The orthocenter is this. The line that contains the altitudes of the triangle are concurrent at the orthocenter. Remember, concurrent means where they all intersect. The orthocenter of the triangle can be inside, outside, or on the triangle. Okay, for an acute triangle, the orthocenter is going to be inside of it. For a right triangle, the orthocenter is going to be a point, and for an obtuse triangle, the orthocenter is going to be outside. So find the orthocenter of a triangle. So triangle ABC is given the coordinates. So here's how we're going to go through this process. We're given 3 sets of coordinates. We need to know the coordinates of the 3 vertices. We need the intersections of the point at the triangle's altitudes. So we need to write an equation that contains the 2 altitudes and then solve. Step 1, find the equation of the line containing the altitude of AC. Well, what do we know about the altitude of 2AC? Well, we know it's going to be perpendicular to AC. Since it's perpendicular, we know it's going to have an equation of x equals something. We know it's going to go through the B value. It's going to go through the B vertex. The x value of B is 2, so the equation is x equals 2. So we have that equation. Step 2, find an equation of the line containing the altitude to BC. So we find the slope of BC of -1. Since the product of the slopes of 2 perpendicular lines is -1, the line containing the altitude of BC has a slope of 1. That slope passes through vertex 1, 3, so we write an equation using point slope form, y minus 3 equals 1 times x minus 3, which simplifies to y equals x plus 2. All right, the orthocenter, we just solved this 2 system of equations. We just replaced the x with 2, so y equals 2 plus 2, y equals 4. So we found the orthocenter as 2, 4. Okay, so let's just really briefly go over all the the neat things we learn about triangles. Where the perpendicular bisectors all intersect is called the circumcenter. And the circumcenter is equidistant from all the vertices. The angle bisector, where all the angle bisectors intersect, is called the incenter because it's always going to be inside the circle. And that point is equidistant from each segment. The median is where all, or the centroid is where all the medians intersect. And what do we know about that? Is each segment length is a perfect ratio of 2 to 3. The altitude, where they all are concurrent, is called the orthocenter. Alright, so here we go. Triangle DEF has vertices of 1, 2, 1, 6, and 4, 2. What are the coordinates of the orthocenter? Alright, well, once we plot it, we notice we have a right triangle. So the orthocenter is just going to be the vertex of the right angle. Since angle D is a right triangle, segment D, or point D, is going to be the orthocenter. Not a lot of work on a right triangle. Alright. Let's go through this. Triangle ABC has vertices of -1, -5, 1, -2, 4, and -1, 1. What is the equation of the altitude of AC? Well, we know AC is a horizontal line, so the altitude is going to be something going vertical. So we know it's going to be x equals -2. So we have an equation of x equals -2. So what is the equation? X equals -2. What is the slope of BC? Well, the slope of BC is just the y of C over minus y of B over the x of C minus the x of B. We do the math. We get a slope of -3. You can see my work right there. What is the equation of the altitude to BC? Well, what do we know? We know it's going to go through point A. Point A is -5, 1. We have the slope of -3. So we know it's going to be perpendicular, not perpendicular, but it's going to be the opposite reciprocal for the slope. So the slope's going to be 1/3. The point is there, so we're going to use point slope. Y minus y1 equals m times x minus x1. Y minus our y1 is 1. Our slope is 1/3. X minus x1, x plus 5. We do the math. We get y equals 2 once we plug in our x value of -2. So we found the orthocenter at 2, -2. Alright, we'll do a couple more of those later. Make sure you understand how to find the orthocenter. It's nothing major. It's just finding the slope of a line and then plugging in the equation of the line that we did all last chapter. And that is 5-4 in a nutshell.